This is Unit 2, Matter, Lesson 1, Types of Matter. How is matter classified? By the end of this video, you should be able to say to yourself, I can differentiate between compounds, mixtures, and elements. I can determine if a mixture is homogeneous or heterogeneous, and I can identify the number of atoms and molecules in a substance based upon the chemical formula. So, to do now review questions. So, you've heard the term matter before. Matter is defined as anything that has mass and takes up space or volume. Some things that are not matter include light, heat, and sound. Generally, if it's a type of energy, it's not considered matter. We can divide matter into several different ways. The first question, if we have something, does it have a variable composition? If not, we will define that as a pure substance. Pure substances can be separated into simpler means. Well, we would ask ourselves, can they be separated into simpler means? Substances. If not, then it's considered an element. An element is the simplest substance. If it can be separated, that is considered a compound. So elements and compounds are both pure substances. If I have a variable composition, then that would be a mixture. Then we would ask ourselves, is the mixture uniform throughout? If not, we consider that heterogeneous. It has an uneven, it's not uniform. However, if it is uniform throughout, we consider that homogeneous, a homogeneous mixture. So those are our vocabulary words that we'll be working with um, in this unit. So pure substances, to take the definitions further, has a definite composition. Each substance has exactly the same composition. They also have definite properties. Pure substances can be made up of one type of atom, such as an element, for example, iron, gold, oxygen. All of our elements on the periodic table, which we'll learn a lot more about soon, are pure substances. However, we also classify compounds that may have two or more types of atoms combined chemically as pure substances, such as salt, sugar, and water. Each one of those are compounds which are considered pure substances. Elements are substances that cannot be broken down further. They're made up of the same atoms. They have our element symbols, which we are going to write the first letter is always capitalized, and if there's a second letter, it's always lowercase. For example, hydrogen has a capital H, nitrogen has a capital N, and lead has a capital P and then a lowercase b. Monoatomic elements are composed of single atoms not bonded to each other. So many elements in their pure form are monoatomic. For example, sodium or helium. And here's a particle diagram as how we represent it, which we'll discuss later. Diatomic elements are two of the same elements bonded together, such as hydrogen, H2. So we represent them as two of the same elements together, and they always come in a pair. There are 7 diatomic elements that you must memorize, and we can remember them by using the phrase Brinkelhoff. Brinkelhoff. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So you need to memorize these. You must always remember that these 7 elements are diatomic molecules. There are 7 diatomic molecules. Nitrogen is atomic number 7. The 6 atoms NOF, C, Br, and I, they form a 7 on the periodic table. That leaves one more, which is hydrogen, which is atomic number 1. So that's another way you can remember it. Or 7 up. Nitrogen is number 7. It makes a 7. And then one more up is hydrogen. Compounds are made up of 2 or more different atoms chemically combined. They have a fixed composition. So that's an important phrase to remember. They can be separated chemically back into their simpler substances. And we're going to represent that by 2 or more different capital letters, such as carbon dioxide. The subscripts are the little numbers that follow an element symbol. This indicates the number of atoms of only that element in the compound. For example, in H2O, the 2 tells me I have 2 H's, and the O tells me there's only 1. We never write the little 1 after it. It's always implied. In carbon dioxide, there's only 1 carbon. However, because that subscript 2 is there, that's telling me I have 2 oxygens. Coefficients are the big number in front of a formula. They indicate how many molecules you have. So, for example, 3 is the coefficient. It's in front of our molecule of H2O. Therefore, I have 3 um, water molecules. And that's what that coefficient is telling you. So try very quickly. How many molecules of water are indicated by the formula 2H2O? So we want to know how many molecules of water. So that means we're going to look at this number in front, which is the coefficient. Because I've got 2, that means I have 2 molecules of water. Of H2O. Mixtures have 2 or more different substances that are physically combined. Therefore, they have varying compositions. So these are some ways to remember your vocabulary. There are 2 types of mixtures: homogeneous mixtures, which are substances that are uniformly mixed, they're all even. All solutions, you can star that. We're going to talk a lot about solutions, are homogeneous mixtures. So, for example, salt water, which we denote as NaCl aqueous, this little AQ tells me it's dissolved in water. So, you should take note of that. That is a mixture of salt and water. A heterogeneous mixture are substances that are not uniformly mixed. For example, oil and vinegar and sand and water. They have they're not mixed evenly, essentially. So quickly classify as a compound, element, or mixture. NaCl, this S denotes that it's solid. If I have it written as a solid, that just tells me that it is all by itself. This is a compound, and a compound would be labeled, classified as a pure substance. Because on this second example, I have NaCl aqueous, this tells me it's dissolved in water. Therefore, this is a mixture. I have the sodium chloride mixed with water. Check your understanding. On your packets, fill in the matter flowchart found there. So, at the end of this lesson, some objectives. You should be able to differentiate between compounds, mixtures, and elements. You should be able to determine if a mixture is homogeneous or heterogeneous. And you should be able to identify the number of atoms and molecules in a substance based upon the chemical formula.